Sorry guys, you cannot see my notes.
Inevitably, this ends up happening, right? It's we can't. Doesn't matter how early you show up. Something always changes right between.
Are you on a Mac?
Yeah. All right.
You might have mirroring on if you want to turn that off.
Oh, it's good.
Okay.
I can see my notes on my laptop, and you guys cannot. All right. So thank you for introducing me, and thank you for giving me this opportunity to have this presentation. So my talk today, the name here is different from the one on the meetup because I decided to change it the last minute because this is more fun. I call it AI Minions, playing with collaborating LLM agents, and you can see the obvious reference to the movie out there. I think it's a pretty appropriate references. For many of us, one fantasy that I have, and I think some of you might have, is in the very near future we'll have teams of AI. Teams of AI agents do everything for us, while we sit back and relax and enjoy our lives. I am fascinated by the futures, and I spend some of my free times learning more about this space and tinkering with some models, some frameworks on how to spun up AI models, connect them together so that they can do tasks for me. I hope to share some of what I found with you guys today, and I know I will learn a lot from you guys during our discussion. I want to start by looking back at the time of like around 2 years ago, the tipping point of AI and LLM, when ChatGPT burst out into the scene and then get into the public awareness. When it first released, I think all of us saw it as like a chatbot, a simple chatbot. We asked it the questions, and then it gave us an answer, and then we asked another question, and it gave us another answer. Some of those answers are very good, even very impressive, and a lot of people spend like a lot of time with ChatGPT since 2022. I think it's like one of the fastest apps to get to 100 million users, if not the fastest one to do so. And that is like proof of how good the model works. But it's not good enough. After like a brief honeymoon period with ChatGPT, just like all of my exes, I start to notice there are shortcomings. They tend to like hallucinate a lot, even when no drugs are involved. They make things up very confidently. They also struggle to do math, to compare simple numbers, or to count the number of letter R's in the word strawberry. And that problem has only been like recently solved by the latest and greatest O1 model from OpenAI. And still then, I think sometimes they still get that wrong. And so these models by themselves are very, well, they are very good at something, and they are very stupid when it comes to actual logical thinking and reasoning. And another disadvantage of these models, limitation, is that they have a limited context window. That context windows have expanded a lot over the past few years, and now we have models with like 1 million tokens context windows. I think that's the Gemini model from Google. That's great, but even with the long context model, the model still tend to miss details about your prompts when your prompt gets bigger and bigger. Like that's the phenomenon called loss in the middle thing. So it's pay a lot of attention to the start of your question and the end of your questions, but any details that you stuck in the middle tend to be ignored by these models. So all of these limitations have motivated people to try to come up with different ways to enhance the LLM's capabilities. All of these strategies and techniques later rebranded as agentic design patterns for LLMs, just so like it sounds cooler. And you can go to VC funders and tell them that we are building AI agents. We're not not just a language model anymore. So I will go through some of the common agentic patterns to enhance LLM capabilities now. The first one is called reflection, and that sounds very philosophical. It sounds like we are turning this AI model into like Socrates or Descartes or someone else. But it's actually just a very simple technique of like, if the model doesn't give you what you want, then you get the error message and you give it to for the next prompt and tell it like, you did it wrong, here's the error message, and then try to fix it. That's what I do very often when I try to use the model to help me with coding, because for coding problems, we can see the error message pretty easily, and the model can, because they have been trained on a very big corpus of coding tasks, they can understand the error message pretty well as well, and they can try to fix it. And this works quite often, but not always. And I don't remember how many times I was like rage quitting ChatGPT when it keep looping back to the same errors, even after it apologized to me that, I know what you meant with that, I know what you meant, I know what I did wrong, let's try this. And then it's like, gave me the example. And so reflection is cool. It gave us some improvement, but it's still not good enough. And so there are the second layer, the second level of agentic pattern, which is tool calling. And this is, when I first learned about this, it's really opened my mind quite a bit. I think this is a lot more exciting than reflection because, with this, we can equip the LLM models with an infinite amount of tools. And these tools can be as simple as a Python function that we attach to the model. So here on the diagram are like two of those very popular tools, a web search tool and then a code execution tool that we can give the model for its usage. And these have a lot with hallucination because with like web search, the model can actually go online and get our actual data, actual information on the internet and use it as context for its answer. And then code execution really help with all of those math questions. Like before, if you ask us to do like comparing 9.1 with 9.11 with 9.8, it will tell you that 9.11 is bigger than 9.8 because that the 1 part is 11 and 8 is smaller than 11. But if you give us an actual function that it can execute, it can run some Python code to compare two numbers and then give you the right answers. And so code execution tool was awesome. And I use it, I equip my models, either personal use or for my projects at work with a function tool like this quite often. So for these tools, the model itself no longer does the reasoning. What it does is it takes in the user's input in natural language and then pass those often messy or vague prompts into a structured format that can be given to these tools. And then after the tool runs and give you some results, the model can synthesize the output of those tools into some coherent, natural sounding, easy to understand answer in English. So that is a pretty neat symbiosis, I think, between a model that is probabilistic and a set of tools that is deterministic. Well, that was cool. And after tool calling, people level it up to what they call planning. Basically, these are models that know, given a task, they know if they should use a tool, they can make a plan of how they should use the tool, and they can assess if the tool calling was successful and lead them to the right answer. So on here is a diagram of one of the most popular class of planning agent called React agent. The React part stands for reasoning, and act, reasoning is actually planning. So it takes in the prompt, it takes in the request, it will start to think of like a list of steps that it needs to do, and then for each step it will try to guess if it needs to use a tool. If it does, then it will call that tool. It check the output of the tool to see if that output is the answer that it's looking for. If that's not the answer it's looking for, then it will look back for another reasoning iteration, then come up with another tool calling if need be, and then another second round output. The loop repeats and repeats and repeats until it sees that, it thinks that it gets the right answer. And so React agent was pretty powerful. And when they work, they actually a sight to see, to watch. But they still are pretty fragile and not 100% all the time reliable. So I think those are the three, up to now, the three levels of agentic design that I have seen. And at this point, I think this is the midpoint of my presentation. I want to do a quick recap of like a few definitions of what people call LLM agents. The fancy one is they are LLM systems that can reason and plan and execute their plans with or without tool calling until, and they can also reflect and refine their answers until they reach their goal, their answer. The casual definition, the one that I actually think to myself when I think about LLM agent, is basically these flow of prompts and prompt outputs that we chain together, and we pass between different instances of LLMs until we force it to give us a solution to our problem. Now with that, this is the highest level and also the main topic of today's talk, which is multi-LLM systems. The first time I heard about this idea was last June or something, over a year ago, when I saw this paper coming out from Stanford Research Group. It wasn't like for any actual application or solve any task. It was like more than a fun game, fun simulation. Basically what they did was they spun up 25 instances of GPT 3.5 Turbo, and they put them together, cohabitate in this one village they call Smallville. And they give each of these agents a name, personality, some habits, and some relationship with some other agents. And these agents are actually pretty complex in their cognitive architecture. They don't just like, they are not just vanilla ChatGPT. They are equipped with a complex kind of brain with memory stream, like they remember their interaction with other agents and with the environment of the village. They have the reflection mechanism. So like after every day of the simulation, they will sit down and think through what they've done that day, who they have talked to, what they have interacted with, and create some higher level abstractions of memory. Like I think this is the equivalent of like people sitting down at the end of the day and do some daily journaling. I don't, but in that aspect, these are better than me. They do actually reflection. And then they also have a planning system that allows them to come up with ideas and then collaborate with other agents in the village to execute this idea. And so the researchers let these 25 agents roam free in their sandbox for 2 days. And then during those 2 days, they observed some emergent behaviors. Basically, these agents, they started to form new relationships with each other. Like when we start the simulation, they only know like a few of the 25, but then at the end, they get to know the whole village. And also, they thought of ideas for parties. I think these are Valentine's Day parties, and they know how to like organize a party. They know how to send out invites. They know how to like teach up each other to spread the words about the events, and then coordinate to come to the event together. That was really impressive. But to me, Smallville was more than an experiment. I think to many people it was a lot more than an experiment. It pointed to the direction of system with multiple LLMs living together, collaborating together to solve things. And also, they point to the very real possibility that we're actually living inside a very complicated simulation. So that's just kidding, but this study was among the first to explore the idea of multiple LLM system. And the more I think about it, I think there's very good reasons that we should have more of this system in the future to solve our tasks and to build software around. And just using a simple vanilla single LLM system with like ChatGPT or Claude or something. Those are very powerful models, but they alone have the like ceiling of their reasoning capabilities and task solving capabilities. So here are some of the why behind like why do we want to put LLMs up. The first thing is many LLMs together, even many weak LLMs like an 8B model working together, they can solve tasks, even complex tasks that some very strong LLM like ChatGPT, like OpenAI 01 or Claude Sonnet 3.5 cannot solve. Most of the time, because with these multi-LLM system, you can break down a complex task into smaller subtasks and then assign the subtasks to these LLMs. These subtasks are easier. They are easy enough for a small LLM to solve. And then after they solve those things, we put together a solution back into a final big solution for our task. Another thing is the fact that those small LLMs can be cheap to run. Like an 8B model costs like I can run it on this thing. So it's free, basically free. They could be very capable if we fine-tune them properly. Like for an example, I found this article on Medium where they fine-tuned the 5.3 mini model from Microsoft. That thing was like 3 billion parameters, so like tiny. But that 3D models can outperform Claude 3 Sonnet in the very task that it has been fine-tuned on, which is to extract entity from free text into a knowledge graph. And so small and cheap and even better than big models, I think that's very good. And the last advantage of these of the system that use this model is they can be run locally and privately, and so the worries of sharing your confidential data with samplement, you don't have that worries. You don't have to worry that he will promise that you will not use your data for training new models or anything against you, but you never know. So yeah. Another thing. I've been talking OpenAI quite a bit, but actually I found this post last month on Twitter. Nolan Brown is the senior researcher at OpenAI, and this post from him is looking for research engineers for their new multi-agent research team. So in this post they say that you don't need to have multi-agent research experience to join. That is, I think this is to say that this field is still pretty new, and the talent hunt will be fierce. And if you want to make some nice cash and a lot of money, then multi-agent is one research direction you can think of getting into. Okay. This is an example, like a real-life example of one multi-LLM agent that actually did something. It's called chat dev, and basically this when our minions, our AIs in Smallville, decided to start a company together, a software company together, and they decided to have a CEO, a CTO, programmers, and everything to automate the software development process. So in this paper, the researchers, I don't know why my laptop's they break down the whole software development thing into phases, and then each phases really break down into subtasks. And for each subtask, they assign a few LLMs to take care of those subtasks. And these LLMs have their roles. So when they prompt this LLM into existence, when they prompt this LLM into existence, those LLMs are given a personas and a specific roles in the company. And then they have a flow of prompts going through the entire process to control and direct the software creation journey. So you will start with a prompt that specifies what kind of software you want to build. That will be the first input. And that input will be given to the CEO AI, CEO agents, and the CTO agents. These two will talk to each other and then come up with some ideas of what kind of software, what kind of features they will need to develop. And that idea, that rough sketch, will be passed down to the CTO and the programmer agent. These guys will work together, they will write out some code, and then they will have some iteration, like looking at the code, see if it makes sense, if it's working okay, and then if that's good, the code files along with the ideas, the high-level ideas, will be passed down to the programmers and some reviewer who will read the code again more closely, more carefully, and then discuss with the programmer about how to improve it, how to make it run faster, how to take care of edge cases, things like that. And after they are confident in those code, the code will be passed for the last round of review between the programmer and the tester. And if that's cool, after a few iterations, they will deploy the code to production. So this is a pretty, I think, a pretty close simulation of how an actual software company works. And the researcher of this paper, they compared their crew of AI agents with some other methods. One of them is called GPT engineer. That is a single agent software developer AI. And this thing beat the crap out of that. In terms of like code completeness, meaning if it's actually write out the entire code base for you, or it will still leave like holes in the code base with like a definition of the function and then pass, and then you have to fill that in yourself. So in completeness, in terms of code completeness, in terms of code executability, meaning it runs properly when you run the software, and in terms of code quality, meaning like how good, how optimized the code is. This thing is a lot better than GPT engineer, and it was also compared to another multi-agent approach called meta GPTs as well, and it's still a lot better. And when people like actually have human validators come in and then ChatGPT-4 come in to compare the code, the chatbot with GPT engineer and meta GPT, they consistently win as well. So that is to say that with careful design, with careful role assignment, and good control of the prompt flows, these LLM, multi-LLM system can already do some impressive work for us. And as the field progress, as the model becomes smarter and faster to run, I think we can automate even more complex tasks, more difficult tasks, for a lot cheaper price. So it's not too cool. Okay. Now the question is, how can you guys start to build something like Chattel, or something even better than Chattel? The good news is there are already several frameworks and toolkits out there that are open source, and that you can use to play with building and controlling and monitoring these multi-LLM systems. I listed some of them here. The Crew AI is a big one. LangGraph from LangChain. I hate LangChain, by the way. Llama Index, Haystack. AutoGen is a good one from Microsoft. And then I think last week or 2 weeks ago, OpenAI themselves released Swarm, which is another open source library for coordinating multiple LLM agents. It is still pretty new and lacks a lot of features, but because it's from OpenAI, I guess it's good for what it does. So for the last section of the talk, I want to show a quick demo of a multi-LLM crew that I built for this talk, and I built it with Llama Index. Not because they are the best, I don't think they are, but because I'm trying to learn about that framework. And the crew that I have built is like basically a publishing house crew. It's like a software development company. This is a publisher, and they publish short stories to the general public. I made prototype. It's still a prototype, so it may work. it may not work, but I hope it will. And to basically the way this program works, this group is I give this a topic or a short story, and it will do some research on the internet about that topic to gather source material. It will write the stories and then will send the story to several downstream agents for further embellishments. Those agents include critic agents who write a review about the story, a translator who translates the story from English to Vietnamese because I'm from Vietnam and that's my mother tongue. There'll be a PR agent who will read the story and then write a short, catchy social media post about the story online so that it can get people's attention. There'll be an illustrator who will read the story and then draw a painting that illustrate the story. And there will be an audiobook narrators who will turn the text of the story into an audiobook that people can listen to like on Audible. So I will have to put my code screen on here. So this project, I built it in a Jupyter notebook. So please don't judge me, it's not production ready yet, so it's still in a notebook. But, so the topic that I picked was, in order to illustrate some point was this new thing called a Keynote color soft. I'm a very big reader, and so a few days ago, Amazon released this new Kindle with like colors. Up until now, they only have like black and white pages, and this had colors. So I really liked it, and I wanted my publisher to write me a short story about Kindle color soft. So I will. This is our own code, and I am happy to go through it later about how it works. But when I start the thing, it will prompt me like, what kind of topics you want to write about. And I write, oh my goodness. Please tell me if I spell things right. Kindle color. Okay, run. I always start running it. It will take a bit to run because some of the model takes longer. But the first thing it does is it takes a topic, is go online with some web search, and take the top 5 results and then extract the content from those results into these 5 lines here. And then these will be the source materials for the short story. Now, when it's run, I want to show you the diagram that I made of this here. I need to explain how things works behind the scene, like the actual flow of prompts and stuff. So thanks to Jason for introducing me to draw that IO. This is a diagram. Basically, you start with it's hard to read, but basically you start with the story topic, and then that story topic will be sent to a source material researcher agent. That agent will go online, search the web, get you some source materials, and then pass the source material to the writer agent. The writer agent will take that and combine that with his fantastic literary talent to write us a short story. And then that short story will be sent to 5 next level agents for processing. The critic agent, the PR agent, the translator agent, the illustrator agent, and the audio narrator agent. And then after all outputs from those things are completed, they'll be compiled together into a final package. That part of the thing takes about a minute to run. Is it done? Oh, it's done. Cool. I want to talk a bit more about some of these agents because they demonstrate some of my points earlier. The first thing is why the source material agent is equipped with the web search tool. So we can equip this agent with any kind of tools we want. The second thing is we have specialty agents here. We have the illustrator agent is a text-to-image agent. The audio narrator agent is a text-to-audio agent. And then the most special one is the translator agent because it's not, the other agents are instances of OpenAI API. But that one is actually an open source model called CLM that has been tuned to be very good in Southeast Asian language, including Vietnamese. It's a very small one, it's 8 billion, but it's actually better in Vietnamese than ChatGPT. And I'm running it locally right now on my MacBook. So just to show that you can have both closed source API agents models as well as local models running together in one workflow. And then some of those local models will be better for your purpose than OpenAI. Okay, so I guess we're done. I think the output is still in the publication folder. There is another folder called publication draft, and that is the backup plan. If like this thing doesn't work I think it will be pretty hard to read the text here. But I don't think we have to read it. I will check to see if the illustration is good. So basically, it tries to, I guess, this tablet-looking thing right here with colors in the keynote color stuff. And I haven't read the story that's created that, but probably this is about classroom students sharing stories together, and one of them is reading from the Kindle. Now the reason why I went with an audiobook version is because I don't think people will read the whole story, but people may want to listen to it. So I will play that.
Title, the last page. In a not-so-distant future, when the lines between the digital and physical worlds blurred to ink-smudged boundaries, the Kindle Colorsoft became more than just a reading device. It was a portal, a conduit for stories that pulsed with color and life. Mira, a dedicated teacher, held the Kindle Colorsoft in her hands, captivated by its vibrant display. The school had upgraded from dull black and white screens, and in their place lay a 7-inch marble that promised to turn every lesson into a sensory experience. With each tap, text came alive, illustrations bursting forth in hues never seen in static ink. One afternoon, as the sun dipped below the buildings, illuminating her classroom in a warm glow, she selected a story about a distant planet painted in shades of emerald and sapphire. As her students gathered, the tale spun threads of adventure and wonder, colors dancing with each word. "Can we visit it?" one child asked, eyes wide. Mira smiled, knowing that each tale now held the potential to ignite their imaginations. With a little imagination, we can go anywhere. As they journeyed through interstellar forests and oceans of crystal blue, something remarkable happened. The Kindle, with its 150 ppi touch of color, began to the artwork danced, asking for participation, pulling colors from the children's laughter, their unbridled joy transforming the static images into a living canvas. But as the final page turned, coloring their shared memory in shades of gold, the screen dimmed. They lingered in the moment, time stretching itself like the horizon. The Kindle's advanced battery life ran low, but it had gifted them something far more valuable than mere entertainment. Next time, Mira promised, we'll explore the ocean on the Colorsoft again. It was too $279 to 99 cents worth every cent, not just for the tech, but for the way it spun their dreams into realities. In that small classroom, the Kindle was not merely a device. It became their gateway to the universe, one color at a time. As the last glow faded, Mira knew this was just the beginning. The Kindle ColorSoft was more than a gadget. It held the power to transcend worlds, making every story a vibrant adventure waiting to unfold.
Yeah, so Amazon should pay me for that. It has all the details you need, like $279.99, colors, and 150 PPIs. So yeah, those are up-to-date information that is not available to OpenAI API because their knowledge date is like something last year, just to show that the web search tool is working okay. And then it actually did a good job of reading the story out loud. I guess the voice is good. And I also want to check the translation. Just a quick check because I can't help myself. This is the reviewer. This is the audio style. This is the short post. Yeah. I guess this is decent. I guess OpenAI ChatGPT can do worse. But yeah. So that demo concludes my presentation. I hope it was fun. I hope it provided something new to you guys. And if you have any questions about this or LLM agents in general, then I will try to answer if I know. If I don't, then I will ask my agents. Thank you. Yeah.
So was it the combination of the prompts and the model you chose that is what you defined it to be an agent? Because you obviously fed different models different tasks to do. So in your mind, it became separate agents because you called different models with different prompts. How did I hope you can get the question out all that rambling.
Yes, so I think in this case, I call them different agents because some of them are different models. But even for a system that only call different clones of ChatGPT, for example, I will still call each of them an agent. It's not more like because they are separate or they are different models, but because it's a good abstraction for me to think about how to break down the task. Yeah.
Thank you.
So what parameters did you use to like differentiate between, let's say, illustrator versus translator?
Yes. So the code is hard to read, but so when I instantiate any of these agents, what makes them different from the other one is just like identity prompt or system prompt I give to them that tell them you are someone, you are person A, you are person B, you are good at this, you are good at that. Like when I created the creative agent, I will tell the model that you are veteran publishing house editor and reviewer for short stories. Please read this story carefully and give thoughtful reviews. But when I created the Illustrator agent, and I will tell it that you are very experienced and talented artist. Please read this story and create a prompt for an illustration for that story. So the identity that I've given each agent, each clone of ChatGPT was what differ, like what makes them different from the rest of the crew. Yeah. Yes.
You mentioned you don't, or this isn't your favorite framework, Lam Index. What is your favorite framework currently?
I try to avoid political questions. But right now, I think there's a new one. I can try to show it to you guys. It's new, and what I like about it is it too long? Oh, I think. Yeah, that's one. It's a second. I'm sorry, that screen is so hard to read. I think the focus is a bit off. So this is the one that's my current favorite.
Okay.
So it's new and it doesn't have as many integration and tools and features as something like Lam chain or Llama index. But it's very, I think it's the most elegant so far. It makes creating prompts and doing like versioning of prompts very easy. It was created with multimodality in mind, meaning you can easily pass in images or audio or video into the prompt, and it will understand those. I think this is what developing with LLM should be like. Because at the end of the day, those LLM programs are mostly like training from together and like based on the logic of the prompts to decide what prompts to write next. So they have very good support for that. What else? I think it also have good support for structured output, which is awesome. I think in order for us to make more complex programs, being able to generate structured output reliably would be necessary, if not essential. Oh, and the guy who created this was an ex-OpenAI engineer, and he openly stated that he made this to kill Lam chain. So yeah, awesome. I like that. Yeah, so that is my current favorite.
You mentioned the journaling process with Smallville.
Yeah.
Do you see, I mean, are all of these just prompt or chain prompts, or is there any mechanism where they can advance and learn? What happens to that journaling? Is it a true learning experience? Do they differentiate over time?
If by differentiate you mean calculus thing, no. But so memory, so that journaling thing was part of their reflection thing was part of their memory stream, and with more memories over time, they do actually change their behavior according to that, because the memory will basically provide extra context to any future responses that they have.
But the memories are effectively just part of the prompt stream. There's
Yes.
no other mechanism. There's no knowledge graph or anything being as a supplementary source.
For that paper, yes. But I think there's nothing that prevents people to like record conversation between LLMs with humans or LLM with each other, save them because I use text file, save them and then turn them into a knowledge graph, and then equip the model with that knowledge graph. So that for any future interaction, you can go back and run queries on that graph, pull out information from its memory, and use that for future answers. So at that point, it's no longer just text in the prompt. It will be an excellent tool that the model can call. And I think that is actually what you're saying is actually what people are doing to advance the capability of these models. Yeah, great question. Yes.
I am curious about a couple of things, but I use AI a lot for text search.
Yeah.
So I have a PDF or something, or I have just a bunch of text, and I will use, I'll use the Google, like, it's not Google Gemini, but it's like a little test thing on the web that you can do.
Is
You
that
can
true?
upload larger PDFs.
Mhm.
You have like, you know, upload up to like 1 million tokens.
Mhm.
But as you know, like sometimes that's not enough, or sometimes the more tokens you have, the harder it is to get the information you want.
Yeah.
And so I'm just curious what your text search best practices are. How would you go about effectively getting a lot of good information, maybe 100,000 tokens, up to like 400,000 tokens?
If I have a good answer to that question, I will not be here. I'll be in Silicon Valley and trying to pitch Sequoia A16Z for like $1 million, $10 million. But I think right now the most common solution to that problem is retrieval augmented generation. And so when you have a very big corpus, like many PDFs, a lot of words, the first thing they will do is, people will do is when user put in the prompts, they will run a vector search or keyword search or hybrid search on that prompt against the database. And then from the database, they will pull out the most relevant pieces of information. But that process doesn't actually use LLM. It doesn't need to. Some of them actually do. But it doesn't need to use LLM. It's just a standard retrieval engine. And then after the retrieval engines find the necessary information that the system, not the model, the system need to answer the question, it will return that to the LLMs, and the LLM will take the question and all the context information that it was given and generate an answer from it. And that basically equips the LLM with infinite memory. The reason why it's not a perfect solution is one, getting out the retrieval process, making it work reliably and actually returning good context is very hard. This depends on your domain of application, depends on the nature of your PDFs, the documents, how you define your corpus into channels for indexing, how many of those, how much context you need to retrieve to give a good answers, how to actually search for a good answer. Would vector search be enough? Keyword search be enough? Those are all unsolved problems. Especially when you want to do something very general purpose. Like at work, when I have to build a RAG system like that, it takes a lot of tuning model parameters to get it right. And even then, it still fails from time to time. So,
Thank you.
So in the beginning part of your talk, you described 3 major agents, and one of them was tool calling.
yes.
So I'm curious about a little more concrete example of that. Like, I'm trying to understand what part does the model do, what part does the tool do? Because in my head, I'm thinking, I would love it if someone did all these little menial tasks that I have to do. After I do my research, I want to present results, say. And I've written Python to create, say, a PowerPoint so that I can give it to my collaborators. But my Python code is never good enough. So I'm thinking, can one of these agents help me with that?
So let me try to clarify the questions. Do you want the agent to help you write better Python code? Or do you want the agent to be able to use the Python code that you have written?
I want something to create the PowerPoint deck for me.
Oh, okay.
Can an agent help me with that? Or maybe I should look for something to help me write better Python code.
I think there are already commercial solutions for that problem. So my answer is yes. Do I know how? I am not sure. But I think Microsoft Copilot, the one inside PowerPoint, can do some simple slide generation for you. And I think Google Gemini on Google Slides can also do that. I don't know if they have open access to those features to everyone. I don't have access to them.
So
I've
just-
seen demos.
So
Yeah.
then to step back, I still don't really fully understand how one of these tool calling things works with an LLM.
Okay. Then I can talk about that.
Great, thank you.
So basically, tool calling in the context of a Python function as a tool works something like this. You write the functions, and then you have some documentation about the functions, like this is what the function does, this is expected input, which is expected output, something that you normally put in the docstring of the function. And then when you equip the LLM with that function, it will read through the function code, and it will read through the documentation of the function, so it knows what the function does. When the prompt comes in and the LLM thinks that it should use the tool, the Python function, it will extract information from the prompt into arguments that the function needs to run. Yeah, and then it will pass that into a function, and then let the function run. And after the function runs, it will take the output from the function and show that into the answer for you.
Great, thank you.
Yeah. I think, yes.
Well, so as all of us have experienced, the boss said, well, you need to make the app be agentic, because that's what the buzzword is in the industry. So you need to take what we're building and make it into agents. So one goes to Medium and starts reading articles about what agentic AI is, and they started throwing words around like large action model or a small action model, and then my head spins, and then the weekend comes, so I clear it with beer. Now it's Monday, and I've got to try and figure out what a large action model is. And do you have an answer for that?
I will try.
Okay.
Yes. So I think, and if anyone knows about it, please don't feel free to speak up. But so I think a large action model is basically this large language model that have been one equipped with tools and can take action, and two, they have been explicitly fine-tuned on examples of how to select tools and how to use tools. Like I think one of the large action models that is new, I think it's one that came out from Salesforce. I think it's called the XLAM family of model. And I think what they did to train though is they took a base model like Lam Vo, and then they either have human created examples of like step-by-step reasonings and step-by-step tool using as training examples for Lam Vo, and then they fine-tune Lam Vo on those examples. And then after that, after all those fine-tuning, when you give the model a task and a set of tools, it will be better at knowing if you need to use a tool or tools, and what tools you need to use, and how to take the results of the tools and put that into a final solution. So I think, in short, what I understand what large action models are basically large language models with tools and have been trained to use tools.
Okay. Thank you.
Yes.
Lam, does Llama Index or any of these other frameworks that you've been experimenting with, do they support like feedback loops? Like, so I know that like you in your flow diagram you had like the editor,
Yes, they do. I don't know about LangChain, but I know Llama Index support feedback loops. In their new Llama Index workflow set of functionalities, they do. The reason why I don't have it in my demo was I was lazy, and I didn't have time to implement those. But it's actually pretty simple to implement feedback loops inside Llama Index workflow. For that functionality, I think they use like event-driven abstractions, and so each step of the workflow is a function. Inside the function is the LLM doing something, and each of those steps will produce some package, and you can pass the package from step to step, from function to function, for the next function to process the package. And then you can pass the package around, you can pass it sequentially, parallel, or in loops until you are satisfied. So the answer is yes.
Thank you. Any other questions? No, I think let's thank Lam for. So we definitely have the space for a little bit longer. Please eat pizza or take pizza. Don't make me bring it home, right? And of course, our next meetup is going to be November 18th with Cassandra. That's very close, I know, to Thanksgiving, but hopefully there'll be still a few people here in town, and we hope to see you then. Thank you very much.
I know, the only reason I knew about the tennis, I